Welcome to my channel. As a first topic of mathematical method, I am going to discuss about unit vector. So a vector whose magnitude is unit is called a unit vector. In rectangular coordinate system, we can write a vector A like I a1, j a2 plus k a3. And the magnitude of a vector we can be written like mod of vector A equals to a1 square plus a2 square plus a3 square and its square root. So the magnitude is square root of every component square value, and then the unit vector A cap we can express is like vector A by magnitude of the A, that is I a1 j a2 k a3 by root over of a1 square plus a2 square plus a3 square. Now scalar product, which is also called dot product. So in physics language we can say dot product written like is a product A dot one vector equals to say vector A, P and the cos theta. Length of the projection theta is the angle between vector A vector and vector B. You can along see in the diagram also. So A dot B. So in physics language we can say dot product is a product of one vector, say vector A, and the length of the projection of other vector along the first vector, that is P cos theta. So now how do we find the angle between two vectors? Since A dot B equals to AB cos theta, so cos theta equals to A dot B by AB, that is AX BX plus AY BY plus AZ BZ plus divided by their magnitude AOX square AY square AZ square root over into root over of BX square BY square BZ square. Now we start with vector product. Vector product is also called the cross product, and it is written like A cross B. So A cross B equals to A B sin theta and a unit vector n. So here n is a unit vector which indicates the direction of this cross product, as you can see in the following diagram. So the direction of this cross product is perpendicular to the plane which contains vector A and vector B. We have drawn this in this figure. So this cross product we can write it in matrix form like I, J, K and their component A1, A2, A3, B1, B2, B3. And the important information is this result of the vector product gives the vector area of a parallelogram. Now let's check some formula about vector dot product and vector cross product. So the first formula is I dot I equals to Z dot Z equals to K dot K equals to 1. That is self dot product is 1. I cross J equals to K, J cross K equals to I, and K cross I equals to Z. So if you see in the diagram, there are I, J, K in rectangular coordinate form, and they all are perpendicular to each other. So if I put I, J, K in clockwise direction, we get the result in this way. It's an interesting way. Again, A cross B equals to, we can write like minus B cross A. So that cross product is non-commutative. That is A cross B and its direction is upward. So B cross A, its direction is downward. The fourth formula is self cross product equals to 0. That is A cross A equals to 0. Because the angle between same vector is 0. So sine 0 equals to 0. So self cross product equals to 0. And similarly I dot J equals to Z dot K equals to K dot I equals to 0. Next topic is scalar triple product. Product of three vectors can be written like A dot B cross C. In a scalar triple product, the dot and the cross are interchangeable in a certain way. So we can write A dot B cross C equals to B dot C cross A equals to C dot A cross B. And the geometrical interpretation of this scalar triple product is it represents the volume of a parallelepiped with edge vector A, B and C. You can see in this diagram. So A dot B cross C, this scalar triple product we can write in matrix forms in component wise like modulus of A1, A2, A3, B1, B2, B3, C1, C2, C3. And remember, if A dot B cross C, that is scalar triple product of three vector, is 0, then these three vectors A, B and C are said to be coplanar vector. That is, three vectors remain in a same plane. Now our topic is vector triple product, that is A cross B cross C, and we can write it B A dot C minus C A dot B, that is back cap rule. You can remember it this way. So in matrix form, the vector triple product we can write the following way: A cross B cross C plus B cross C cross A plus C cross A cross B equals to 0. Reciprocal set of vectors. It is a very important topic, especially in solid state physics. Two set of three non-coplanar vectors like A, B, C and A prime, B prime, C prime. They are said to be reciprocal set of vectors if they satisfy A dot A prime equals to B dot B prime equals to C dot C prime equals to 1. This is the main condition. And also A dot B prime equals to B dot B prime dot C or equals to B dot C prime or any other dot product is 0. So now we can express this reciprocal set of vectors in the following way, like A prime vector is equals to B cross C by A dot B cross C, B prime equals to C cross A by A dot B cross C, and C prime equals to A cross B by A dot B cross C. Similarly, we can also write in case of vector A, B prime cross C by A prime dot B prime cross C prime, and the V vector and C vector can be found in this way. Volume V, which is A dot B cross C, represents the volume of a primitive unit cell, and V prime is the A prime dot B prime cross C prime, represents the primitive volume in reciprocal space, and this V prime equals to 1 by V. And the scalar product is always invariant in normal and reciprocal space.